So this is what they say to us. The circuit diagram below consists of a battery, a switch, an ammeter, and a glowing light bulb, which is connected in series. A voltmeter V is connected across the light bulb, as we can see in this beautiful sketch. So this is our sketch. It's a very simple and basic sketch. All right, the battery has 3 cells, but that's not the point. The switch is already closed, which means there is current flowing through the battery. And this is what the first question is saying. It says the reading on ammeter A is 0.4 amperes. And furthermore, they say 432 joules of energy is transferred to a light bulb in 3 minutes. Calculate the reading on voltmeter V. Well, that's what they say. Now, with regards to the energy, we know that at least, or as far as grade 10 is concerned, there is only one formula that has to do with energy. It's the one that says V equals W divided by Q. That's the one. So W is the energy, or it's the work done. So we know it in the numerator, but we are looking for V. In order for us to find the V, that's if we know the Q. Do you see that? We already have W in the numerator. We just need Q, which is the amount of charge in the denominator. And then we can gladly find the V. But now, how do we find the Q? Well, Q is the amount of charge, and we get it from the definition of current. Current is the rate of flow of charge, which means it's Q divided by change in T. And they gave us the amount of current. They also gave us the time. Ours is just to go on and find the Q. That's just it. It means you have to know your formulae and also know what does each symbol in the formula mean. And it's easy to connect the dots. That's just it. Science is not all bad. No, it's not all bad at all. So let's go. And always make sure that your time is in seconds every time you are in physics, paper 1. Always. They will trick you. Every time they give it to you in minutes, that's because they want to check. Do you remember that you need to convert? Because no one will tell you that you need to convert the time to seconds. No one. You won't get that hint at all in the exam. Let's begin. We say, well, the current strength is defined as the rate of flow of charge. This is what we know. And now we say, well, the amount of current that's flowing through the second, it's given to us as 0.4 amperes. We are looking for the amount of charge. And the time, they gave it to us in minutes. They said it's simply gonna be 3 minutes. So you can put your 3 here and multiply it by 60. Because 1 minute, there are 60 seconds. So in 3 minutes, we have 180 seconds. You could have decided to write 180 there. but 3 by 60 is perfectly fine as well. And now you can cross multiply. So when you go into your calculator and I go into mine, which was given to me back in 2019, and I press this, I find that the amount of charge will be 72 coulomb. Yes. And now it's easy to find the potential difference. We can just go on and say, well, it's defined as the amount of energy per unit charge between 2 points or across 2 points. And now we can go on and say, but the amount of energy is given to us as 432 joules. And the amount of charge, we just got it now as 72. And so when you say 432 divided by 72, you find that the potential difference across the battery, sorry, not across the battery, but across the light bulb will be 6 volts. But the light bulb is a resistor, right? And there's only one resistor in the circuit. And since it has a potential difference of 6 volts, then it means it's still the same as the potential difference across the battery. That's what we say. Over and out.